All right, so in this video, we're going to be looking at the external ear and the middle ear. These are a bit more simple in terms of structure and function than the inner ear, the internal ear with the cochlea. So we'll pack these into one video and then we'll give it its own video. So for the external ear, let's just have a quick look at the anatomy that we're dealing with here. This is really the full hearing system. The external ear is just the pinna or auricle. That's the visible part of the ear, what we colloquially call the ear. Then the ear canal or auditory canal, also called the meatus, just Latin for path. And then the tympanic membrane or the eardrum, that is the barrier between the external ear or outer ear and the middle ear. And now, it's not just a passive site for sound to travel along. Because of its shape, the auricle can give some indication of where a sound is coming from. You'll notice that certain frequencies are attenuated as they come around from behind, whereas if they come from the front, those sounds aren't attenuated. So the same sound can sound a little bit different coming from behind than from in front. The auditory canal itself, the ear canal, is a tube, so it has acoustic properties and boosts certain frequencies relative to others. And then the tympanic membrane, the eardrum, has properties that can attenuate really loud or really high-pitched sounds. It doesn't vibrate quite as coherently, and that can attenuate those and help prevent them from damaging the more delicate structures inside. And and then that's transmitted. That's the end, by the way, of the journey of sound through air for hearing. So it travels through the air to get to our ear, and through the auricle, through the ear canal, and then once it hits the tympanic membrane, it's no longer going to be traveling through air. In the middle ear, it's going to be transmitted through these bones, and then in the inner ear, it gets transmitted through a fluid. Okay, so let's move on to the middle ear. So the middle ear is mainly a cavity. I'll go back to the image in just a second because I know it's a bit more informative than me waving my hands. The middle ear is mainly a space between the tympanic membrane and the oval and round windows at the other end that we're going to be talking about with the inner ear. And that cavity is called the tympanic cavity. And the most interesting stuff going on there is these little bones, these little gray bones here, the malleus, incus, and stapes, or hammer, anvil, and stirrup. And these bones are responsible for taking the vibrations at the eardrum and transmitting those vibrations through to the oval window, which is on the edge of the cochlea here. And as they're doing that, they're also amplifying the pressure a little bit. Part of how they do that is that the eardrum has a greater surface area than the oval window. So the same amount of force or energy on a large area concentrated onto a small area it amplifies the pressure. And the other has to do with the leverage, the relative leverage as you go through this system. It increases that a little bit. Okay. Another function of the the middle ear, is to keep pressure equal. Remember when we were first learning about sounds, and we learned that although the sound is changes in pressure, and there are other changes in pressure in the atmosphere. The thing about sound, it's lower amplitude changes in pressure, right? The amount of pressure change that you have in a given sound is much less than the amount of pressure change, for example, when the weather turns from cloudy to sunny or rainy or whatever. But the thing about sound is that it happens faster. If the middle ear were a completely enclosed space, then it wouldn't be a very good way to transmit sound, because that eardrum has to be sort of loose and flexible so that it can respond to those small changes in pressure that we have with sound. If this was an enclosed space, then whenever the outside atmospheric pressure dropped, the greater pressure inside the middle ear would push that eardrum out and sort of bulge out like a balloon and get really tight. And something tight can't vibrate freely like we need the eardrum to do. And similarly, if the pressure outside increased, it would push that eardrum in and it would bulge out like a taut balloon in the other direction. And again, it wouldn't be good for reflecting those vibrations. So the eustachian tube, which we see at the bottom of this diagram, that sort of pink passage heading down towards the nasopharynx, that is a way of equalizing pressure. And in fact, whether you know it or not, apologies for what this does to the sound, any microphone is a lot like the middle ear, right? There's a the atmospheric air pressure outside. Then there's a cavity. In that cavity, the membrane that vibrates, much like our eardrum, it moves back and forth and it induces some electrical current, and that's all a little bit different than what happens in the ear. But there's a space in there, and that space has to be isolated from the outside world, because if it wasn't, then sounds would push from both sides of it, and you wouldn't get that movement. Same with the eardrum. We want sounds to just push on one side so that they push in and out instead of from both sides, and it'll just sort of cancel out. But you need some way to equalize with those larger amplitude, slower changes in pressure to do with weather and whatnot. And in a physical microphone, an electronic microphone, there's always some like hole in the side of that chamber so that pressure can be equalized. It can be a small hole. Small hole doesn't transmit sound through very well, but air can leak back and forth slowly, which is what you need for those large and slow changes in pressure. The eustachian tube is that hole in the side of the microphone chamber. And you'll notice, when your ears pop, if you're changing altitude through driving or riding an airplane or something like that, that's what's happening, is the eustachian tube, which is usually kind of collapsed closed. The difference in pressure from inside and outside is large enough that it pushes some air in or out, depending on which way you're going. Okay, but the actual transmission of sound for hearing is done from the tympanic membrane through those ossicles, those little bones, the 3 smallest bones in the body. I guess technically 6, because most of us have 2 ears. Through that solid medium to the inner ear through the oval window. Okay. And I encourage you to look at the textbook for some more details on things that the ossicles and the muscles attached to them can do to attenuate sound if there's a really loud sound coming. So look into some details there. They have a lot of different jobs. But basically, so we've looked at the outer ear or external ear in this video and how it shapes the sound as it's coming into the ear. And then the middle ear from the eardrum through the 3 ossicles to the oval window, and how that ultimately ends up transmitting the sound from the air in the outer ear through the solid ossicles in the middle ear into the perilymph, the liquid medium in the inner ear, which we will be learning about in the next video. Can't wait.